So we are going to move on to properties of quadrilaterals. So this is chapter 6, LT3 and LT4, being able to identify a quadrilateral and use the properties. So here is the quadrilateral family. They all stem from the quadrilateral, which is just a basic four-sided shape. And from there, you can be a kite, a parallelogram, or a trapezoid, depending on your properties. And we're going to talk about those. From there, the kite pretty much just hangs out by itself. The trapezoid, you can have an isosceles trapezoid, which is going to have similar properties to an isosceles triangle, as well as a right trapezoid. That's not on this picture, but that can be there too. And then the parallelogram, that's where you have a lot of shapes that you guys hear about more often, just in general, which are going to be your rectangle, your rhombus, and your square. And they're going to share properties based on this. So what you want to remember is, as you go through the list, every next shape on a line has the properties from the one before it. So a rectangle has all the properties of a parallelogram. A rhombus has all the properties of a parallelogram. But the rectangle and rhombus, they're not connected. So they are going to have different properties than one another because, as you can see, they're not connected. And then a square is going to have all of them. So now we'll talk about that. A basic quadrilateral, it has four sides and angles add up to 360 degrees. So that's your first part of the quadrilateral family, or those two facts. Going from there, if you move on to a kite, it has two pairs of consecutive sides congruent. Here's what that looks like. It's those ones on the top that are next to each other. Consecutive means next to, or those ones on the bottom that are next to each other. In a kite, the diagonals are also perpendicular, so you're going to have four right angles where the diagonals meet. The next shape we're going to talk about is a trapezoid. A trapezoid has one pair of opposite sides that are parallel. So in this case, we call those the bases. It's the top and the bottom based on what we're looking at. And the consecutive angles are supplementary. So remember, supplementary means adds up to 180. And that's A and B. So those would be consecutive angles, or the two on the left here would be consecutive. They're going to add up to 180. As a reminder, this indicates that these sides are parallel, not congruent, but that they are parallel. The next shape where we focus a lot of our attention on, the next shape in the trapezoid family is the isosceles trapezoid. So again, it's going to have the parallel sides, the consecutive angles supplementary, but it's also going to have congruent legs. And these base angles that I'm showing you are also congruent. So those are the properties of an isosceles trapezoid. The top are also considered base angles because you could flip this around and it would be the same. So those are also congruent. But again, the consecutive angles add up to 180 together. Now, what I meant to say was the parallelogram. This is where we spend the most of our time. So a parallelogram has a lot of facts. A lot of them just make sense like when you look at the shape, but here is the list. So both pairs of opposite sides are parallel. They're also congruent. So like two long legs, two short legs, kind of like a rectangle, because a rectangle is a parallelogram. Both pairs of opposite angles are congruent, so the ones across from each other. Consecutive angles are supplementary, we just talked about with the trapezoid, and diagonals bisect each other. So here's what that looks like visually. The opposite sides are congruent, so they're the same, so like 2 and 2. Opposite angles are congruent, G and J, they are opposite angles, as are H and F. Consecutive angles are supplementary, so that's like H and J, or G and H, they would add up to 180. And the diagonals bisect each other, so they cut each other in half, making those two parts equal to one another. We're going to practice with all of these soon, but you just want to make sure that you have your properties down. A rectangle has everything the parallelogram had, but in addition, a rectangle has four right angles, which hopefully you know just by logic. And a rectangle also has congruent diagonals. So those diagonals from corner to corner, those are going to be the same length in a rectangle. Moving on to a rhombus. Again, a rhombus is a parallelogram, but what makes a rhombus special is that it has four equal sides. Its diagonals are perpendicular, so they have four right angles where the diagonals meet. And the angles are bisected in a rhombus. So the diagonals bisect the angles. So like let's say angle R was 120 degrees. That diagonal creates two 60-degree angles at the vertex. So those are your three special properties about a rhombus. Now a square, as you can see if you follow the path, a square can line up with everything all the way back to a quadrilateral. So a square has all of those properties. So everything I just said, the properties of the parallelogram, the rectangle, and the rhombus, all of it. The square has all of those. So now we're going to use these to figure out some answers. So the area of a square is 100 square inches. What is the perimeter of the square in inches? So we got to remember that we have 4 sides that are equal, so we could call them all x. Area is base times height, or side times side, so x times x is 100 because they told us the area. And then we can do some algebra to solve for x. So take the square root and we get x equals 10. They're asking for perimeter, so 10 plus 10 plus 10 plus 10 is 40. Next one, number 2. We have an angle that's 70 in a parallelogram, and they're looking for the rest of the angles. So in a parallelogram, we know that opposite angles are congruent, and also that consecutive angles add up to 180. So the ones that kind of stack with one another, so whether you're looking at it up and down vertically or left and right, they're going to add up to 180. So 180 minus 70 is 110, and that's how I'm filling those in. I'm using the properties. Number 3, we're given a rectangle, and we're told that we have a length of 8 and 15. Well, I know that a rectangle has a right angle right there, and I'm hoping you might be seeing the right triangle. So we can use good old Pythagorean theorem. We haven't talked about it in a while, but there is Pythagorean theorem. So we can use that to solve for c squared, which is the diagonal in this rectangle. And when you do that, you get 17. You guys can plug and chug and, figure that stuff out, but you would just use your algebra to get you back to 17. Now we're in a rhombus, and they're telling us that the diagonals are 10 and 24. So in the picture, they have it split up because a rhombus is a parallelogram, so the diagonals do bisect each other. So even though this whole thing is 10, we can break it into 5 and 5. Same thing for the 24. They're looking for the perimeter. So I know that all sides in a rhombus are equal, but I also know that these 4 angles are right angles. So that leaves us with 4 separate right triangles. There's a right triangle here, next to it, to the left, etc. And we can use the Pythagorean theorem to solve for that missing side, because 5 squared plus 12 squared is going to equal the hypotenuse squared. And just in case you're not seeing those right triangles, I'm just going to, it's not wanting me to work here. I'm not getting the pen to work. Let's try. Okay, there it is. So there's your right triangle, and 13 is the hypotenuse. The perimeter, therefore, would be 52 units because you would add all your sides up. Next one, 3 angles of a quadrilateral are given. What is the 4th angle? We got to remember that all quadrilaterals add up to 360 degrees. So if we add the 3 that were given, we have 323. We subtract that from the 360 and get 37. Next example, MN is the median. We talked about medians way back with triangles, but the median of the trapezoid. And I'm going to label what they gave me. So in a trapezoid, because you have parallel sides, these are going to continue to go sequentially. So if I know that 54 to 42, that distance is 12, I'm going to do 12 again and get to 30. We're not going to deal with the medians too much, but I did want to show you guys an example of it. Number 7, we have a parallelogram ABCD. And I'm going to label all the angles that they say here. So angle 1 is 78. And then they tell me that the measure of angle BAD. So if you remember, that means that whole angle. I put the 60 on the outside just because I didn't want to make myself think it was either, this one that I just put a dot in or this one that I just put a star in. I wanted to know that it was the entire angle. And we're looking for the measure of angle 2. So in a parallelogram, you have parallel sides, obviously. But you also have these consecutive angles. So this one and this one, these angles, the whole things, I know my phone's ringing, I'm just going to ignore it. These entire angles add up to 180. So that's where I got the 120 from. And now I see that I have this 78. So 120 minus 78 is 42. And that's where that other piece comes from. Perimeter of the square whose diagonal is 3 radical 2. I know that looks kind of scary, but don't worry, we're going to get rid of it. So we know a square has a right angle. We have 3 radical 2 as the diagonal, and we have all equal sides. So all 4 of those sides are the same, so we can call them all x. So do a little bit of algebra for this, and I'll walk you through this in class. But we're doing algebra, so we get x squared plus x squared is 2x squared. When you type this entire thing into the calculator with the parentheses where they belong, you'll get 18. As you can see, it's no longer scary. X squared ends up equaling 9, and therefore x equals 3 because you take the square root. So then you have 3, 3, 3, 3, and your perimeter is 12. I wrote it out because I think I accidentally went with 9 as my answer. So 12 is going to end up being your perimeter, but I think the PowerPoint might say otherwise in a second. But 12 is the perimeter. And again, be careful when typing, so you ignore that. Be careful when typing those parentheses into a calculator to make sure that it does what you are asking it to. We are given a rhombus in this example. They're telling us that AD is 10 as it's labeled. AC is 12. So I'm going to choose to label that as 6 and 6 because a rhombus is a parallelogram and the diagonals are bisected. So therefore I could put 6 and 6. And they're looking for the length of BD, which is that other entire diagonal. So they're looking for this entire piece. Again, I know that the right angles are going to happen where those diagonals intersect because the diagonals are perpendicular. So I see that I have, I'm going to hopefully show you here with the red, I have a right triangle right there. So I can again use Pythagorean theorem. We've done that a lot if you haven't been able to tell. And I can solve for B and get 8. Once I get 8 for B, for that length of ED, remember that was just here, so it's also there because it's bisected, and then I get 16. It's kind of like a giant puzzle. Last one, I think. So we have the rhombus here. The measure 74. They want the measure of angle MAH, so we're looking to end up here. I labeled my opposite angles congruent, so I got 74 degrees. And now I also know that consecutive angles are supplementary. So this angle here and this angle down here add up to 180. So that's how I got the 106. And now another property of a rhombus is that the diagonals are angle bisectors. So I know that I can have 53 on both sides, on either this angle up top or the angle on the bottom right. Oh, I lied. It wasn't the last one. Sorry. Given parallelograms, so we have a parallelogram again. We have bisecting, some vocabulary we haven't used in a while, and we're looking for the measure of angle MBT. So I labeled my opposite angles congruent. My consecutive angles add up to 180, so that's where that 60 came from. And now I'm just going to use some properties of bisecting to get me the rest of this. So I have 60 degrees in the other corner because opposite angles are congruent, and therefore I have 30 on each side. And now if you look, you have a quadrilateral within this quadrilateral, so that's a four-sided shape. All four of those angles should add up to 360, and that's where the 150 comes from. All right, we have a rectangle. They're telling us that we have a 55-degree angle, and it's labeled, and we're looking for the measure of angle AEB. So in a rectangle, you have a 90-degree angle in all the corners, and then you're going to have alternate interior angles because a rectangle sides are parallel, just like the other ones, because it's a parallelogram. That's what I mean by the other ones, all other parallelograms. What also happens in a rectangle is that this side and this side, because the diagonals are equal, those are equal. So you create an isosceles triangle. So that's why I just labeled that other angle as 35 degrees, because base angles in an isosceles triangle are 35 degrees. And that is how I'm going to fill in the rest of these, just using those exact same properties. And now you'll see that there are 4 triangles, and I'm going to use the fact that the 3 angles in a triangle, so this triangle that I'm highlighting in the green, they add up to 180, so 35 plus 35 is 70. Subtracted from it, 180 is the 110. So they're all like giant puzzles, and you just use the properties to figure it out. I hope you have a great day, and I'll see you in class.